Have you ever wondered how scientists describe things that move, like cars racing on a track or aeroplanes soaring through the sky? To understand movement, we need rich language and clever tools. This is where scalars and vectors come in. Imagine you are running in your garden. You could say, I ran 20 meters today. That's good information, but is it enough? What if your friend wants to know which direction you ran, towards the apple tree or the playground? Telling them just the distance isn't quite enough for them to picture your run. This is the big idea. Scalars are simple. A scalar is a quantity that only has a size, or magnitude. It doesn't tell you anything about direction. Think of temperature, 23 degrees Celsius, mass, 4 kilograms, or time, 10 seconds. All these are scalars because they just tell us how much of something there is. Vectors, on the other hand, are more adventurous. A vector has both a size and a direction. If you ran 20 meters towards the apple tree, that's a vector. It tells us not just how much you moved, but which way you went. To help picture a vector, imagine an arrow drawn on your notebook. The length of the arrow shows how much, the magnitude, and the way it points shows the direction. For example, the wind blowing 10 meters per second towards the east is a vector. Physicists love working with vectors because they help describe movement and forces clearly. Let's learn how to write them. Vectors are often written using component form, which just means splitting them up in two parts. Imagine your garden as a grid, and suppose you ran 5 meters east and 12 meters north. Your vector can be written as 5, 12. The first number is how far east, the second is how far north. To find out how long your run really was, you can work out the magnitude, the size, using a clever trick called Pythagorean theorem. For your run, the magnitude is the square root of 5 squared plus 12 squared, which comes out to 13 meters. The direction can be worked out too by thinking about the angle your run made with the eastward line. Vectors can also be added and subtracted. If you ran 5 meters east and then 12 meters north, your total run is just adding up those movements. The result is another vector. If you double back, some numbers become negative, showing you're moving the other way.